Hello guys, welcome back to the Quantity Surveying workshop and to another video. In today's video, we're going to be starting our measurements properly for the framed structure. In the first video that we did for this series, we treated how to read the structural drawings for a framed structure. So with that details that we've gotten from the structural drawing, we're going to be using it to begin our measurements for the substructure properly. So as you can see on the left hand side, you can see the taking off list for everything we're going to be measuring for the substructural works of this frame structure. So the first is what? The site clearance, followed by the site preparation, which deals with the removal and disposal of topsoil, then the column pit excavation, then the foundation trench excavation, after which we will now do our measurements for the leveling and compaction, then the anti-termite treatment, then we will now do the blinding to the column pit and to the trench. The way I've listed this taking off list, I've listed it in such a way that it follows the process at which they actually do the construction. So after the blinding to the column pit and to the trench, we can now do our reinforcements to the wall for the column basket. Then after the reinforcements to the column basket, then the reinforcements to the what? Starter bars. After that, we will now measure for our what? Stirrups. Then after the stirrups, we will now do our what? Concrete in the foundation. So after the concrete in the foundation, we will now also be doing our concrete in the what? Column footing, then the concrete to the what? Starter columns. After which we will now start was laying our block work. So we will now measure the block work in the foundation as 2 to 5 mm, and then the block work in the foundation 150 mm, if any. In our CESMM, they said that we have to measure it separately. So after that, we will now do our what? Backfilling. This backfilling is also what you know as filling obtained from excavation. So it is stated in your CESMM as filling obtained from excavation instead of what? Backfilling. But it can also be said to be the backfilling. Then we will now do our laterite filling, then the hardcore filling, after which we will now do the BRC mesh, then measure for the damp-proof membrane, and lastly the oversight concrete. So doing all this, measuring all this in our taking off list, will be completely measuring for our what? Substructural works for this frame structure. So without any further ado, let's get right into the video. So the first on our list is the what? Site clearance. So you know that when you are being taught in school, when you are trying to measure for your site clearance, you first determine your spread and then add twice spread to the length and the width in order to get the area that you are going to be clearing your site. And then in some cases, all they do is just to add workspace to both the length and the width on both sides in order to get the area. But that approach is usually used when we are not giving the site plan. So you just get the total length of the floor plan, add your twice spread or your workspace to both sides, do the same thing for your width, and then you get the area. But in this case, we are giving the site plan, which makes things easy. So this site plan now that you are seeing on the screen is what is the total area of that site that we are going to be what? Clearing. So in the drawing, they say that the length of the site is what? 29,000 millimeters, and then the width is what? 20,000 millimeters. So that is the parameter that we are going to be what? Clearing. So you know that your site clearance is measured in what? Meters square. So we're not going to be doing any serious calculation here or any deduction. So we're just going to be going straight to the point. So the first thing we're going to be doing, we're going to be what? Describing. Clear site vegetation. Shrubs. And other growths, and dispose of sites. So this is the measurements for our what site clearance description. Then we will not do the measurement. So our length is what 29,000 millimeters. You convert it to meters, so that is what 29.00, and then our width is what 20,000 millimeters, which is what 20.00 in meters. So when you do the math, 29 times 20, because it's a meter square, and you know meter square is length times breadth, so 29 times 20 is equal to what 580 square meters. So we'll write it here, 580.00, and then you close. So doing this, you measured for the what site clearance. So the next thing on our list is the what site preparation. Now site preparation is all about the removal of the topsoil. So you know that the total area that you've cleared for your site is still the same total area that you are going to be what removing the topsoil, unless stated otherwise. So this area 580 square meters that we are clearing for our site, but also going to be what clearing or removing the topsoil as much as this was 580 square meters. So for the site preparation, you know that the site preparation entails the removal of the topsoil and the disposal of the topsoil. So we are now going to describing, right? We will now say removal of topsoil, comma, average depth not exceeding 150 mm deep. And our site preparation, removal of topsoil in our CESMM is measured in meter square. So the same values that we've measured here, we're going to be bringing it down. 29.00 by 20.00, and it's going to give me 580.00 square meters, and then you close. And then we're now going to be disposing this topsoil from the site. You can now see disposal of excavated materials, of excavated topsoil, from site. So now disposal of excavated materials is measured in meter cube in our CESMM. So we're going to be adding another parameter to this length and width, which is the thickness of the topsoil. So we will now measure the length is the same as what we have before, 29.00 by 20.00, and then the last parameter is the thickness, because disposal is measured in meter cube, and the thickness will be the thickness of the topsoil, which is 150 mm. So when you convert 150 mm to meters, you're going to be having 0.15. So multiply these three dimensions together. What are we going to be having? We're going to be having 87 cubic meter, and then you close. So the last thing we're going to be measuring for is the column pit excavation. So if you watched the video for how to read the drawing, the structural drawings from the frame structure, you would remember that we had more than one different type of column base. It is through the dimension of the column base that we'll know the values or the length and the breadth that we are going to be excavating for the column pit. So in that particular drawing, if you watch the video, you remember that there were 5 different base types, 5 different column base types, right? So we're going to be going into those drawings and we're going to be finding out the values of those, that's the length and the width of those 5 different column base types. So let's go into the working area. So as you can see in the drawing, these are the 5 different column bases, from base type 1, base type 2 down towards base type 5. So all we need to do now is to get the length and the width of all the column bases individually. Remember that the dimension for measuring excavation is in meter cube, meaning that we're going to be needing the length, width, and the depth of the column base. So the first thing is to first determine what the length and the width of each of the different column base types, because you know that it's not only one base type that we have 5 different base types, so we need to be doing them individually. So the first base type, the length is 1200 by 1200. Base type 2 is 1200 by 1200. Base type 3 is 1200 by 2296 millimeters, and base type 4 is 1200 by 2378 millimeters, and last but not least is base type 5, which is 1400 by 1400. So we're going to be writing this down so that we can remember it when we want to do the measurements properly. So let's go back to our taking of sheets. So as you can see, we've written down the length and the width of each of the column base types. So column base type 1, you can see 1.2 by 1.2. We've converted it to meters here so that it can be easy for us. Followed by the column base 2, the same column base 3 down towards column base 5. So the next thing we now need to do is to determine the number of occurrences of these column bases, of the individual column bases in the foundation trench drawing. So we need to know how many places do we have the column base 1, how many places do we have the column base 2, how many places do we have the column base 3 down to the column base 5. We need to know their individual number. So we're now going to be going to the foundation trench details to now determine those frequencies. So as you can see, this is the foundation trench drawing, and through this we're going to determine the numbers of these column bases, the number of occurrences of each of the individual column bases. So we're going to be starting with column type 1. So in this drawing, like I said, when we're doing the structural drawings for this frame structure, I said that anywhere you see BT, it means base type. So all you just need to do now is to find for where there is BT1 and then calculate or count how many numbers of BT1 we have in this drawing. So let's do that now. So we're going to be starting from here. This is BT2, this is not BT. So this is BT1. So we have here 1. Let me just exit. 1. We have another one here, 2. We have another one here, 3. We have another one here, 4. We have another one here, 5. 5. What I can count here is 5. Let's do it again so that we're going to be sure. Anywhere we see BT1. So this is 1. You can see BT1. This is 1. This is another one. So that's making it 2. This is another one, making it 3. This is another one, making it 4. This is another one, making it 5. So BT1 we have 5 in number. So let's go and we're going to now record it. So the next is BT2. So base type 2, we will now do the same thing, count them. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. So I counted 11 base type 2. So let's do it again so that we can confirm. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. Now let's go and record it. So the next one is what? Base type what? 3. So let's count 1, 2, 3. So base type 3 we only have 2. Let's do it. Let's count again. 1, 2, 3. So base type 3 is only what? 2 in number. So we're not going to go and record it. So the next is what? Base type 4. So we're not going to count. So this is 1. So base type 4 we only have what? 1. So we're not going to what? Measure it. So the last one is what? Column base 5. So we're not going to count the numbers. So this is 1, this is 2, and this is what? 3. So column base 5 are what? 3 in number. So we're going to what? Record it. So this is the record of the dimension and the numbers of each of these what? Column bases. So you can see column base 1, these are the dimensions. This is how many they occur. Column base 2, the same thing. Column base 3, the dimension and the what? Frequency. Column base 4, the dimension and the frequency. And column base 5. So the next thing now we're going to be determining is to determine the depth of the what? Excavation for the what? Column pits. So to determine the depth of our column pit, we are going to be using this section that shows us the details of our columns and the column pits. So if you look at this drawing, let me just zoom closer to the substructure so that you can easily understand it. So I hope you can see this clearly. You can see now that from the top of the oversized concrete to the top of the concrete for the column footing, it is what? 1350 mm. And in our detailing for our what? Column drawings, which is this one, you can see that in our section the thickness of the column footing is what? 350 mm, and underneath it there is a blinding of what? 50 mm. So all we need to do now is to determine the total distance from the top of that oversized concrete down to the bottom of the what? Blinding. So since we know that from here, which is the top of the oversized concrete, to the top of the column footing is 1350, we know that the distance from the thickness of the column footing is what? 350 mm. So plus 350, then plus 50 mm blinding is going to give us what? 1750 mm. But this distance that we've measured of 1750 mm is not the actual depth of our what? Column footing, because the excavation for the column footing is going to commence from the what? Stripped level. When I mean stripped level, the level after you've what? Removed your topsoil is called your what? Stripped level. Remember that in the measurement sheet we've already what? Done our site preparation for removing the topsoil. So it means that we need to determine where the level of our stripped, we need to determine what is our stripped level in order to now know where or what is the actual depth of our what column pit excavation. So in order to determine that, we will now go towards our section. So as you can see this section now, from the information given for the substructure, they say that 150 mm thick oversized concrete ground floor, 300 mm thick compacted stone hardcore. I hope you can see this. Please, you can see it. I think there's a feature on YouTube where you can zoom in to see what's actually going on. So all we need is to put these two dimensions in mind: the thickness of the oversized concrete and the thickness of the what hardcore. So now if you look at this part of the drawing, right, if you look at this part of the drawing, you can see that this dimension is what 600 mm. What we are trying to find out now is where our stripped level is. So now the issue now is that this level now that we have here, is it our stripped level or is it our ground level? You know, there are two different things. Ground level is the level before you strip off your what topsoil. Stripped level is the level after you what stripped up your what topsoil. What we need is our stripped level. So to determine whether this is our stripped level or our ground level, all we need to do is this. Since we know that the dimension from the top of the oversized concrete down to this thick line is 600 mm, and within this 600 mm, it harbors the thickness of the oversized concrete and the thickness of the hardcore. We know that the thickness of our oversized concrete is 150 mm, that of our hardcore is 300 mm. When you add the two of them together, you're going to be having what 450 mm. And you know that the thickness of our topsoil is what 150 mm. So if you add 150 mm to 450, you're going to be having what 600 mm. So it means that this thick level here is our what stripped level. Now with this information, now we can now use it to determine what the actual depth of our what column excavation will what be. You remember earlier we measured from the top of the oversized concrete down to the bottom of the blinding for the column footing to be what 1750. That's the distance from here down to the bottom of the blinding for the what column footing. But the excavation is starting from what the stripped level. So all we just need to do now is to minus, since we know the distance from here to the bottom, we can now minus this 600 so that the excavation can start from here down to the bottom. I hope that's easily understood. So all we just need to do now is to minus 600 from 1750 mm distance, and we're going to, what we have is going to be the depth of our what column footing excavation. So let's go to our what measurement sheet and do the maths. So now we want to determine what the depth of our excavation will be for the column pit. So we know that they told us that the length from the top of the excavation to the top of the column footing was given as 1350 mm. So we're now going to be adding the thickness of our what column footing. Of what 350 mm, and then blinding of what 50. When you add everything together, you're going to be having what what we calculated as 1750 mm. But this is not the actual depth of our excavation. Put this here. 1750 mm. So we are now going towards less that distance from the top of the oversized concrete down to our stripped level, down to that thick line that I showed you earlier, which was what 600 mm. So stripped level was what 600. So when we minus this from this, we are going to be having what 1150. So this is the depth of our what column pit excavation. So now the next thing we're now going to be doing is to what describe. The description would state column pit excavation commencing from strip level not exceeding 2 meters deep. So now with this we can now book. So we're going to be starting with column base 1. So column base 1, the length is the dimension is 1.2 by 1.2. So we'll now write 1.20 by what is the thickness we've calculated? 1150. So by 1.15. We'll now multiply it by the number of that particular footing, which we've recorded as 5 in number, and then we will close. We will now do for column base 2, 1.20 by 1.20 by the same thickness, by the same depth, 1.15, multiplied by the number 11, and then you close. We'll now do the same thing for base type 3, 1.20 by 2.296, that's approximately 2.30 by 1.15, multiplied by the number, which is 2, and then you close. We will now do the same thing for column base 4, 1.20 by 2.378, approximately 2.38 by 1.15 by the number, which is 1, and then you close. So the last one is column base 5, which is 1.40 by 1.40 by 1.15 by the number, which is 3, and then you close. So now we're not going to be determining what are the values of these 5 column pits now. So the first one, column pit 1, so 1.2 times 1.2 times 1.15 is equal to 1.656. We will not times it by 5 column pits. So this 1.656 is the volume of excavation for column base 1 for just 1 pit, and you know that we have 5 pits, so we have to multiply that value by 5 to get the total value of excavation for column base 1. So 1.656 times 5 is going to give me 8.28. So we'll do the same thing for column base 2, 1.20 times 1.20 times 1.15 times 11 is going to become 18.216, approximately 18.22. So we'll do the same thing for column base 3, 1.20 by 2.30 by 1.15 by 2 is equal to 6.348, approximately 6.35. So we'll do the same thing for column base 4, 1.20 by 2.38 by 1.15 by 1, and that will become 3.284, approximately 3.28. So the last one will be for column base 5. So 1.40 by 1.40 by 1.15 multiplied by the number, which is 3, and that will give us 6.762, approximately 6.76. So these are the total volume for each of the column bases in relation to their frequency. So after we've now gotten this, we are now going to add everything together so that we can get the total volume for the column pit excavation. So you now have to add this, and this together. So let's do the maths. 6.76 plus 3.28 plus 6.35 plus 18.22 plus 8.28 is equal to what? 42.89. So this is the total volume of excavation for our column pits, and then we will now close. So doing this, we've measured for our column pit excavation. So that would be that for this video, guys. I hope you derived adequate knowledge from it. As you can see, it is as easy as ABC. Please do not forget to like, share, and subscribe to this channel to get premium educational content on your measurements. Thank you, and we'll see you in the next video.